From the moment you're old enough to ask questions, gravity is explained to you in the simplest possible way. Things fall because Earth pulls them. You drop a ball, it falls. You jump, you come back down. You throw something up, it slows, stops, and returns. So the story seems obvious. There must be a force reaching up from the Earth, grabbing objects and dragging them downward. A kind of invisible hand pulling everything toward the center of the planet. That explanation is so intuitive that nobody ever questions it. Not in school, not in daily life, not even most of the time in physics. But here's the first uncomfortable fact. That explanation isn't just incomplete, it's fundamentally misleading. It works just well enough to stop you from asking better questions. Because the moment you slow down and really think about it, the story starts to wobble. What does it actually mean for Earth to pull on something? Pull how? With what? Through what? If gravity is a force like pushing a box or pulling a rope, then something must be doing the pulling. There must be a mechanism, a connection, some kind of interaction passing through space. But space, as far as we can tell, is empty, no ropes, no rods, no physical link between the Earth and the falling object. And yet, the object accelerates. That alone should bother you. Because in your everyday experience, forces don't work like that. You can push something only when you touch it. You can pull something only when there's a connection. Even magnets and electric forces, strange as they are, still involve fields you can measure, describe, and manipulate. Gravity doesn't behave like that. In fact, gravity behaves so differently from every other force we know that calling it a force at all starts to look suspicious. Here's something even stranger. When an apple falls from a tree, we say gravity pulls it downward, but at the exact same time, the apple is pulling the Earth upward. That's not philosophy. That's basic physics. The forces are equal and opposite. So why don't we see the Earth move? The usual answer is, it does move, just very slightly, but that answer hides something deeper. If gravity were really just a mutual pulling force, then both objects should accelerate according to the same rule. Yet one falls dramatically and the other barely responds already. The picture is uneven. Now let's make it worse. Imagine you're floating in deep space, far from any planets or stars, nothing nearby. No gravity, as we like to say. Now imagine someone fires a rocket attached to you, pulling you forward with a steady force. You feel acceleration from inside your body, from inside your experience. That acceleration feels exactly like gravity. Your feet feel heavier. Objects fall down inside the spacecraft. Light bends slightly. Time even ticks differently. And here's the disturbing part. There is no experiment you can perform inside that closed system to tell whether you're accelerating or sitting in a gravitational field. No test, no measurement. No clever trick. As far as nature is concerned, the two situations are identical. That should set off alarms. Because if gravity were a simple pulling force, it shouldn't be able to perfectly mimic acceleration. Forces and motion are supposed to be different things, but gravity doesn't respect that distinction. Now consider another everyday idea, weight. You think you weigh something because gravity pulls on you, but when do you actually feel your weight? When you're standing still. Not when you're falling. If gravity were the thing you feel, then falling should feel intense. You should feel gravity most strongly when you're accelerating downward, but you don't. When you fall, you feel weightless. When you stand still, supported by the ground, that's when you feel heavy. So what are you really feeling? Not gravity. You're feeling the ground pushing up on you, preventing something else from happening. That flips the entire story around. Instead of gravity pulling you down, it starts to look like your natural state is motion, and something is constantly interfering with it. The force you feel isn't gravity acting on you. It's matter resisting a motion it would otherwise follow. That's not how forces are supposed to behave. And it's not how gravity is taught. The childhood story says gravity reaches out and pulls things together. But the deeper you look, the less sense that picture makes. Gravity doesn't act like electricity. It doesn't act like magnetism. It doesn't act like any force you can turn on or off. It doesn't even seem to act at objects in the usual way. By the time you reach this point, one thing becomes unavoidable. Either gravity is a completely different kind of force than everything else in nature, or it isn't a force at all. And once you seriously consider that second possibility, the entire idea of falling weight and motion starts to rearrange itself in your mind. Because if gravity isn't pulling you, then something much stranger must be happening. Falling is not what you think it is. Let's start with something that feels obvious and yet hides the entire problem. When you drop an object, you say it falls. But falling toward what the usual answer is, toward the earth. That sounds reasonable until you realize it doesn't actually explain anything. It just restates the observation in different words. The deeper question is this: what determines the path the object follows through space? Because falling isn't random. The object doesn't zigzag. It doesn't hesitate. It follows a very specific curve at a very specific rate every time. And it does this regardless of what the object is made of. A feather, a hammer, a rock, a drop of water remove air resistance, and they all fall the same way. That should strike you as astonishing. In every other interaction we know, the response depends on the object. Electric forces depend on charge. Magnetic forces depend on structure. Friction depends on surfaces. Even inertia depends on mass. But gravity doesn't care. Everything falls the same way. That means gravity isn't interacting with the object's composition. It's not grabbing onto some internal property and pulling. It's dictating motion itself. Now imagine this. You're standing on the surface of the earth, not moving sideways, just standing still. From your point of view, you're at rest. But from another point of view, one that doesn't privilege the ground beneath your feet, you're not at rest at all. You are accelerating upward. That sounds absurd until you remember something crucial. The ground is constantly pushing you upward, preventing you from following the same path as a freely falling object. If the ground suddenly vanished, you wouldn't feel yourself being pulled down. You would feel nothing at all. You'd simply continue along the path the universe had already laid out for you. So here's the reversal. Free fall isn't motion caused by gravity. Free fall is motion without interference. That's the motion objects follow, when nothing is stopping them. Standing on the ground is what's unnatural. The ground is the thing exerting force. The ground is the thing pushing. The ground is the thing causing you to accelerate away from your natural path. That's why you feel weight when you're standing still. That's why you feel nothing when you fall. Now ask yourself this: if gravity were a force pulling objects down, then free fall should feel like being yanked by something. But it doesn't. It feels like floating, which tells you that gravity isn't acting on you in the way forces usually do. Instead, space itself seems to be setting the rules for how motion unfolds. Think of it this way. In empty space without gravity, objects move in straight lines at constant speed. That's the simplest motion possible. But near massive objects, those straight lines aren't straight anymore. They curve, not because something is pushing the object sideways, but because the geometry of space itself is different. The object is still doing the simplest thing it can do, moving straight ahead, but straight ahead no longer means what it used to. This is the point where the idea of gravity as a force quietly collapses, because if falling objects are simply following the natural geometry of space and time, then nothing is pulling them at all. They're not being acted upon, they're just moving. And the reason everything falls the same way is because geometry doesn't care what you're made of. A straight line is a straight line, whether you're a feather or a hammer. Once you see gravity this way, the equivalence between acceleration and gravity stops being mysterious. Acceleration feels like gravity because it is gravity. When a rocket accelerates through empty space, it creates the same conditions that curved space-time creates near a planet. From the inside, the experiences are indistinguishable. That's not a coincidence. It's a clue. It means gravity isn't something added on top of motion. It is the structure of motion, which leads to a disturbing conclusion. If gravity isn't a force, then the Earth isn't pulling you down. The Earth is reshaping the space and time around it, and you are simply moving through that structure the only way you can. Falling isn't being dragged. It's being allowed. And standing still is what requires constant effort. Once you absorb that, you realize that nearly everything you've been told about gravity has been framed backward. And that backward framing has hidden just how strange reality actually is. Why gravity isn't a pull at all now. Let's confront the word that causes most of the confusion. Pull, we say gravity pulls objects together. The earth pulls the moon. The Sunday pulls the planets. Apples are pulled toward the ground. But every time you use that word, you're smuggling in an image that doesn't belong there. A pull implies a mechanism, a rope, a connection, a force transmitted from one object to another, and gravity has none of those. There's no cord stretching from the earth to the moon. There's no signal traveling back and forth, tugging things inward. Nothing reaches out and grabs, yet motion changes. So where does that change come from? The mistake is thinking gravity causes motion the way other forces do. It doesn't shove objects off their paths. It redefines what a path is. Imagine drawing the straightest possible line on a flat piece of paper. Easy. Now crumple the paper slightly and draw the straightest line again. You haven't changed how the pen moves. You've changed the surface it moves on. The line curves, not because the pen is being pulled sideways, but because straight has changed meaning. That's gravity. Mass doesn't emit a pulling force. Mass alters the geometry of space and time around it. And once that geometry changes, the straightest possible paths curve. Objects simply follow those paths. This explains something that has always been quietly strange. Gravity affects light. Light has no mass. It shouldn't respond to a force that depends on mass. And yet light bends near stars, not because light is pulled, but because it is moving through distorted space. Its path curves the same way everything else's path does. That alone should tell you gravity isn't a force in the ordinary sense. Forces act on things. Geometry acts on everything. Now think about orbits. If gravity were a pulling force, then a planet in orbit would constantly be falling straight toward the Sunday, but somehow missing. That explanation works mathematically. But conceptually, it's awkward. It treats orbit as a failure to fall. The geometric view flips this completely. The planet isn't trying to fall inward. It's moving straight ahead in space-time. The curvature of space-time bends that straight motion into a closed loop. The planet isn't being dragged around the Sunday. It's following the natural shape of space and time created by the Sunday's mass. Once you see this, something unsettling happens. You realize there is no privileged direction called down. Down is local. Down is just the direction in space-time that curves most steeply near a massive object. On the other side of the Earth, down points the opposite way, not because forces reverse, but because geometry does. This also explains why gravity weakens with distance, not because the pull fades like a stretched spring, but because space-time curvature smooths out as you move away from mass. Closer in, paths curve sharply far away. They become nearly straight. No pulling required. Now here's where the idea becomes deeply uncomfortable. If gravity isn't a force, then nothing is ever being forced to move the way it does. Everything is simply following the rules set by the structure of reality, which means the universe doesn't push objects around like pieces on a board. It shapes the board itself. Motion is not imposed. It emerges. And once you understand that, the old image of gravity as an invisible hand pulling things together stops making sense. There is no hand, there is no pull. There is only geometry telling matter how to move, and matter telling geometry how to curve. That mutual relationship, mass shaping space-time, space-time shaping motion, is gravity. Not a thing, a structure. And that structure doesn't care what you believe about it. It operates whether you imagine forces or not. But the moment you stop thinking in terms of pulls and start thinking in terms of paths, gravity stops being mysterious in one way and becomes far more unsettling in another, because now the question isn't what is pulling us. It's what is space really made of, if it can bend like this. And that's where gravity stops being familiar physics and starts brushing up against something much stranger. And that backward framing has hidden just how strange reality actually is. Why weight is an illusion you feel every day. Let's talk about something you experience constantly, yet almost never question weight. You feel heavy standing on the ground, your feet press down. The floor presses back. Your body feels compressed, anchored, stuck. So it's natural to assume that weight is gravity acting on you. But that assumption is exactly backward, because weight does not come from falling. Weight comes from being prevented from falling. The sensation you call weight is not gravity pulling you downward. It's the ground pushing you upward. You can prove this without equations. When you're standing still on Earth, you feel weight. When you're in free fall, you don't. Astronauts orbiting the Earth are still under the influence of gravity, intensely so, yet they float. If gravity caused weight, they should feel heavier than ever. They don't. They feel nothing, which means weight is not a direct signal of gravity at all. It's a signal that something is resisting your natural motion through space-time. Your body left alone would follow a smooth path dictated by the geometry around the Earth. That path curves inward. The ground interrupts that path. It pushes you off it. That pushes what you feel. That is weight. Now imagine a person in a spaceship accelerating in deep space, far from any stars or planets. The engines fire, pushing the ship forward. Inside, the person feels pressed against the floor. Objects fall. Liquids pool at the bottom. From the inside, it feels exactly like gravity, and there is no experiment they can perform. Inside that closed ship, to tell whether the force they feel comes from acceleration or from standing on a planet. This isn't a trick. It's a statement about reality. Acceleration and gravity are locally indistinguishable, which means gravity isn't something special layered on top of motion. It is motion viewed from a curved space-time. That's why free fall feels like weightlessness. You're no longer being pushed off your natural path. And that's why standing still hurts your knees. You are constantly being accelerated upward by the ground, fighting the geometry of space-time beneath you. The Earth is not pulling you down. The Earth is holding you up. Once you accept this, the language we use starts to break down. We say gravity is strong or weak, but what we really mean is that space-time curvature is steep or shallow. We say objects fall faster near massive bodies, but what's actually happening is that the paths through space-time converge more sharply. We talk about gravitational forces acting at a distance. But nothing reaches out. Nothing transmits. Nothing pulls. The structure is simply there. And everything moves accordingly. This also explains why you can't shield yourself from gravity. You can block light. You can insulate against heat. You can redirect electric and magnetic fields. But you cannot block space-time. You cannot put up a barrier and say, don't curve here. There is no gravitational insulation because gravity isn't something traveling through space. It is the shape of space. Now here's the unsettling part. If weight is an illusion created by resistance to motion, and if free fall is the most natural state, then the universe prefers motion, not rest. Stillness is enforced. Movement is default. The feeling that you are sitting still on Earth is a local illusion created by the surface beneath you. From the universe's point of view, you are constantly being shoved upward, deviating from your natural path. And that means our everyday experience is built on resistance, not equilibrium. We feel weight not because gravity acts on us, but because we are refusing to fall. Once you internalize that, gravity stops being a downward force. It becomes a quiet, ever-present rearrangement of how motion is allowed to exist. And that realization sets the stage for the final, most disturbing implication of all. Because if gravity is geometry, and geometry governs time as well as space, then gravity doesn't just affect where things go, it affects when they are. Gravity breaks time before it moves space up to now. It might still feel like gravity is mostly about motion, falling objects, curved paths, weight, and orbits. But that's only half of it. Because gravity doesn't just bend space, it bends time. And it bends time first. Clocks do not tick at the same rate everywhere. That's not philosophy, that's measurement. A clock on the surface of the Earth runs slightly slower than a clock far away in space. A clock at sea level runs slower than one on a mountain. A clock near a massive star slows dramatically. Nothing is wrong with the clocks. Time itself is different in different gravitational environments. And this is not an after effect of gravity. It is gravity. When space-time curves, time is the part that warps most strongly. In fact, the reason objects fall toward massive bodies is because they are moving toward regions where time flows more slowly. That sounds backwards, but it's precise. Objects always try to move in the direction that maximizes their passage through time. Near mass, the fastest route through space-time bends inward. So objects don't fall because space slopes downward, they fall because time does. Space curves because time curves. And motion follows time. This is why gravity can't be eliminated by clever engineering. You can't remove it by going far away. You can't cancel it out. As long as mass exists, time will run unevenly. And as long as time runs unevenly, motion will curve. This also explains why extreme gravity creates horizons. Places where time slows so much that from the outside it appears to stop. Nothing special happens to matter at that boundary. Time simply tilts so steeply that all possible futures point inward. At that point, motion toward the center is no longer optional. Not because of a force, but because there is nowhere else time allows you to go. This is gravity at its most honest. Not a pull, not an attraction, not a mysterious influence reaching across space, but a reorganization of causality itself. Now think about what this means for everything you experience. Your aging depends on where you are in a gravitational field. Your past and future are stitched together differently depending on mass nearby. Even the idea of now is not universal. There is no single clock for the universe. There is no master timekeeper. There is only local time, shaped by mass, flowing at different rates in different places. Gravity isn't something added to the universe. It is the rule that defines how space and time exist at all. And once you see gravity this way, you realize why it resists every attempt to merge it with the other forces. Electricity, magnetism, nuclear forces, these act within space-time. Gravity creates space-time. That's why it feels familiar yet refuses to behave like anything else. That's why it's both the weakest interaction and the most dominant structure. And that's why the old idea of gravity as a simple force has always felt incomplete. Because gravity isn't telling matter what to do. It's telling reality how to be arranged. Once you understand that, gravity stops being something that happens in the universe. It becomes something the universe happens inside. And that's the part people rarely say out loud.